morning, grade 11s, and welcome to another series of videos that we're going to do that is dealing with algebra. And if you do also follow with me with the Mind-Born textbook, if your school's also using that, that is what we are using at the moment, an excellent textbook, I might say. I'm going to do a video that is covering the whole of chapter 1, which is exponents and surds, as well as chapter 2, which is the equations and inequalities. Okay, so I'm going to walk you through. Perhaps you were ill and you missed a part where the teacher was explaining, or you just didn't listen so nicely and you want to recap, or you just want to refresh your memory before going into a test or exam. Then this is the video to watch, especially if you are dealing with exponents and surds and equations and inequalities. All right, so I'm going to take you step by step. I'm going to make it short little videos, well, short as I can make them, on the different sections. And the first one that we're going to look at is the operations with powers containing numerical bases. All right, so the thing that you need to remember here, that is key, you need to break down any base number as a product of its primes. Why do we want to do that? Because of this very word here, simplify. Now, the only way we can simplify is when we've got the same bases. Okay, so when we've got a 2 to the power 3 and a 2 to the power 4, we know then that we can multiply. Why? Because we've got the same base and we apply our exponent rules. We keep our same base and we add the exponents. So now, every number is made up out of a product of its primes. So every number that we have in the whole world is made up out of either a 2, a 3, a 5, a 7, and it's all your prime numbers. Now, your calculator can do that. It can break it down as a product of its primes. I don't know if you can cast your mind back to grade 6 and 7, where you've learned the ladder method, where you had to break down the number into a product of its primes. So now we can just use our calculator. If you've forgotten what the number should be, smaller numbers, easy, bigger numbers, we're going to use our calculator. Okay, so let's quickly have a look. We want to, let me just get a different color here. We want to simplify this. All right. So we're going to look at every base that is not a prime number, and we want to break those down into a product of its primes. Okay. The 4 is easy to see. We know that it's 2 to the power 2. That 2 gets raised up and it multiplies with the n and the 2. Okay. Not just the 1, but both, which will make it 2n plus 4 times 3 squared is 9, and that 2 raises up and it multiplies a power raised to a further power. You multiply together. So 2 times n is 2n minus 2 times 1 is 2. Over. Now 72, you might use your calculator, tells you, so how you put in your calculator, you say 72 equals shift fact, and that gives you 2 to the power 3 times 3 to the power 2. But wait a minute, we need to remember about this n that it was raised to. So both of them, not just the one, but both of them gets the further power n. And that gets timesed with 2 to the power 1 minus n. Okay, and then I always tell my kiddos, you clean up upstairs, you clean up downstairs. Upstairs is already cleaned up. There's a 2 and a 3. There's not much that we can do there. But downstairs over here, we've got a 2 and a 2, which we know that we can multiply together, or not the 2's, but we keep our same base and we add our exponents. So I'm just going to rewrite the top part. And at the bottom, I'm going to take the 2 to the power 3n. If you want to do it on the side, you can. It's 3n plus 1 minus n. That plus won't really affect my signs, but I'm just going to do it in any case. And 3n minus n is 2n plus 1. So it's going to be 2 to the power 2n plus 1 times 3 to the power of 2. Okay, and now we can go upstairs, downstairs. Let's go look. These two can divide out, and those two. Why? Because they've got the same bases. Okay, so now I'm going to take the 2 to the power 2n, I'm going to write it down, 2n plus 4, and I'm going to subtract. Now, very important, people, rather write a few steps than to make a blupsy. Rather write it all out and keep it with your brackets. Okay, so when you're subtracting two terms from another place, you have to do it in brackets so that that negative distributes into the bracket to both terms inside. Okay, so that will be 2 to the power 2n plus 4 minus 2n minus 1. So lots of you will forget to distribute that negative to the plus over there, so just don't do it. 2n minus 2 minus 2, and then you can go and say, well, 2n minus 2n becomes 0, so I'm left with 2 to the power 4 minus 1 is 3 times 3 to the power 2n, oopsie, somewhere I have 2n minus 2 minus, somewhere I've made a mistake, sorry, let me just quickly check, 3 to the power 2n, sorry, I forgot that n, so it's 3 to the power 2n minus 2 minus 2n, there we go, skisi for that, so 2n minus 2n falls away, and then I've got 3 to the power negative 2 left. And now you go and say, all right, I go and make it a positive by taking it downstairs, and then that you can simplify 8 over 9, and you've got your answer perfectly right. Okay, so sorry, like these mistakes happen, I know it happens with you as well, so just make sure that you copy down from the previous section over to the next line correctly. Okay, all right, so let's have a look at number 2. At number 2 now, we've got the HCF. We want to factorize. Why do we want to factorize? Because from this sum, where it was one term altogether, we are moving over to fractions where there's a minus and a plus in between. So we've got 2 terms on top, 2 terms at the bottom. So we're going to factorize. So I know lots of you split it. With my class, I don't know, it becomes too busy, so I always tell them I do it like this. So if there's 3 to the power x on top, I'm going to take out a highest common factor of 3 to the power x. Now the thing that they cannot do wrong is what is left. So if I take out 3 to the power x here, that is now gone, but what is left? Not just 2. Please, it is 3 to the power 2. That 2 is attached to a 3 to the power 2. Minus, and if I take out everything, remember 3 to the power x divided by 3 to the power x is 1. So also don't forget that there's a 1 left. At the bottom, I'm going to take out 3 to the power x. What is left? Don't forget, it's 3 to the power of 1 minus 3, your base 3 to the power of negative 2. And now we can delete out, or we can cancel out that 3 to the power x's, and what is left at the top is 3 squared minus 1, and you are more than welcome to just go pop it into your calculator. That is 8 over, and if you pop that, 3 minus 3 to the power negative 2 is 26 over 9. And people, you can pop that whole thing like that just into your calculator, but if you want to do it step by step, that's fine. Just remember to put it all in correctly, and that gives you 36 over 13. All right, people in grades 8, 9, 10, you were used to like nice numbers. You must get used to haha numbers in grade 11. Okay, all right. Which I mean, it's not as a whole number answers. It's going to get bad. All right. Okay. So I hope you understand that. Let's move on to the next one. All right. So now this one. The first one, so remember with our factorization, we get highest common factor, we get difference of 2 perfect squares, we get trinomials, we get what I call the haha trinomials, where there's a number bigger than 1 in front of the x squared as your first term. Then you also get sum and difference of 2 cubes and group factorization. All right, so those all are types of factorization. So we need to remember that these can all be used because we want to factorize these. Why? Because we've got a minus and a plus at the top, or anything, but there's 2 terms at the top, 2 terms at the bottom. So now, I want to make, just to make it a little bit simpler, I'm sure you've heard of the K method, where I'm going to substitute my 3 to the power x, and I always show it like that, as k. So I'm going to let 3 to the power x equal to k. Now, if I make k, 3 to the power x k over here, can you see that there's a little 2 left? So it's going to be k squared minus 1 over k plus 1. Now that is much simpler to see. Okay, the top part is a difference of two perfect squares. So I'm going to say k minus 1, k plus 1. I'm going to divide out with k plus 1. Those are going to cancel, and I'm left with k minus 1. So just be careful. You need to go and sub it back. So it's 3 to the power x minus 1. With these sums, I always tell my students, only change into prime bases if there is an exponent with an x. So can you see the one that I highlighted here is the 10 that is to the power of x. This 4 is to the power 1, so we're not going to change him into prime bases. We don't have to. The same as this 4 over here. We're not going to change it. Why not? Because it doesn't have a variable like an x or a y attached to it. Okay, as an exponent. So the only one we're going to change over there, and the others are already prime bases. You see the 2, the 5, and the 5, so we don't need to change them. So the only one that has a variable attached to it as an exponent is 10 to the power x. So we're going to change that into 5, and 2, so 5 times 2 is 10. 5 to the power x times 2 to the power x. Both of them get the x as the exponent. Plus 4 times 2 to the power x, all over. Now, remember, the way you can write this is the same as saying 5 to the power x times 5 to the power x, ne? Because what do? You keep your same base and you add your exponent. So just keep that in mind. So if you want to do that, you can, just to maybe make it a bit easier for yourself. 4 times 5 to the power x. Okay, now between these two terms, can you see there's one term at the top, two terms at the top? Okay, so now between these two, look carefully. What is the same? Aha, this 2 to the power x. So I'm going to take out a 2 to the power x at the top. And what is left? 5 to the power x plus 4. So if I take that out, I always circle it like that. That is my highest common factor, and what is left is what is not highlighted. Okay, and at the bottom, can you see that I'm going to only be able to take out 5 to the power x as well? So only thing that's common between both. So if I take out 5 to the power x, what is left? 5 to the power x plus 4. Aha! So those two brackets can cancel out because they are exactly the same, and your answer left is 2 to the power x over 5 to the power x. All right, with these sums, they will say to you without the use of a calculator. So obviously it's easy to go plonk it into your calculator, but they'll say show your steps without the use of a calculator. So now, always think prime bases. I've got a 2 as a prime base, a 2, and a 4. So that 4 can be changed into 2 to the power of 2. So let me just rewrite the top over here. So 2 to the power 2, the 2 pushes up, and it multiplies with the 1006, and that becomes 2012. Almost looks like years of dates these, hey? Now, can you see that I can take out at the top 2 to the power 2013. You could have gone that route as well. That would have been fine. And then simplified further. So if you wanted to do that, 2 to the power 2013. So let's just say the most you can squeeze out of that is 2 to the power 2013. So the one with the lowest exponent. Highest common factor, you take the one with the lowest exponent. Remember that from grade 6 and 7. Okay, so 2 to the power 2013. So what is left? 2 to the power of 2012. Sorry, because if you add those two together, oh, no, not 2012. Sorry, 2 to the power of 2. Because when you multiply it back in, you keep your same base and you add your exponents, which gives me that 2015 plus 1. Okay, so remember, if you take out exactly what is there, there is a 1 left. All right, over 2 to the power 20, 12. Okay, now these two can cancel, or not cancel out. 2 to the power 13 divided by 2 to the power 12. So they've got the same base. So what I'm going to do is I'm going to keep my same base and I'm going to subtract the exponents. What is 2013 minus 2012? Is 2 to the power 1. And there in bracket, if I have to simplify, it will be 4 plus 1. Oopsie, sorry. Which gives you 2 times 5. Oh, sorry, there goes our bell, which gives you 10. All right. Okay, another way you could have done it is you could have just taken out at the top what is needed to cancel out with the bottom. So I'm going to take out 2 to the power 12. What will be left? 2 to the power 3 plus 2 over 2 to the power 20, 12. Those would have cancelled out, and I'll be left with 2 to the power 3 is 8. 8 plus 2 is 10. So it gives you the same answer. Here with number 6, you can see that we've got 3 terms at the top and 2 terms at the bottom. So we have to make it one term to simplify as the original instruction. So we want to use factorization. So first steps first, we need to break down anything that has an x attached as an exponent. We need to break down into a product of its primes. So the 9 will become 3 to the power 2x. That 2 pushes up and multiplies with the x, minus 3 to the power x minus 6. Do I need to change the 6 into a product of its primes? No, because it's got no x attached as a variable in the exponent. So leave 6 alone. Again, we've got 3 to the power x minus 3. Now, if you want to make this easier for yourself, if you can see how to factorize it, that's perfect. But if you want to make it easier, you take the middle term, always the one in the middle with your trinomial, and you represent it as k. All right, so over here, if you represent this as k, your first term will have a k and a square. So k squared minus k minus 6 over k minus 3. I'm just going to change the color as I feel it's a bit light. So I'm going to factorize those two. My trinomial, the signs are different. The first one's a minus, and what times what gives you 6. If you add or subtract, gives you 1. And I'm just going to test it. Minus 3 plus 2 does give you negative 1, and these two multiplied does give you minus 6. All right, that goes over k minus 3, and I'm so glad you can bundle that together if you want. That cancels out, so I'm left with k plus 2, and then I'm going to replace the k back with 3 to the power x that I used in the beginning to represent 3 to the power x with. All right, so there is your answer. All right, let's look at number 7. So if you are a little bit scared of these and you want to first represent it as k, you're more than welcome to. Okay, so first of all, step 1, I always say make the numbers that are not prime numbers into a product of its primes. Only the ones who has a variable attached as an x. So this 16 doesn't have any variable, it just has to the power 1. So we're not going to manipulate or change that one. Okay, so 4 to the power x becomes 2 to the power 2, and the 2 pushes up and multiplies with the x on top. And over here, 2 to the power x minus 4. So if you are a little bit scared, I'm going to let 2 to the power x represent k, and then I've got 16 minus, now if 2 to the power x is k, then I'm left with k squared over k minus 4. So the one that you represent as k is the one with the smallest exponent. So this one is to the power x, this is to the power 2x, so you use the one with the lowest exponent. Okay, so if your highest common factor, you take out the one with the lowest exponent. Okay, and now we can factorize that easily. We can see it's 4 minus k, it's a difference of 2 perfect squares, and 4 plus k over k minus 4. And now you say, oh, it's almost the same, but it's not yet there. It's not exactly the same. So what you can do is, if I had to swap these brackets around, I'm going to do that step by step. So if I swap it around, the term has to come with its sign. So minus k plus 4. So you see, I just swapped it around, but the negative belongs to the k. So that's why it's negative k plus 4 and 4 plus k over k minus 4. So now you say, okay, I'm almost there. So remember your sign change, or not, taking out a negative. So if you take out a negative, then this negative k is going to become a positive k, and the positive 4 is going to become a negative 4. So if I add a negative there, I'm going to be left with a positive k minus 4, 4 plus k, all over k minus 4. So I did all of that so that I could get brackets that's the same. So now I can cancel out that. What am I left with? A negative 4 plus k, and you can distribute that negative in, and gives you negative 4 minus k. All right, this is just an extra one. I'm not going to do it completely, but the lowest common denominator that you can take out both upstairs and downstairs is 5 to the power 2007. So what is left? There's going to be 5 to the power of 1. No, sorry. There, I made a mistake. Okay. People, this brings us to the end of the video. Thank you so much for watching. There is going to be more videos following. This is a basic recap of grade 10 and what we've done with exponents in grade 10. I know that in our school we've already dealt with this in grade 10. It's just maybe a refresher. We've got, remember, if we've got one term like in the beginning, we just do the prime basis, we simplify from there. If we've got two terms or two or more terms upstairs or downstairs, we have to factorize first. Your factorization is HCF, difference of two perfect squares, your trinomials. Those are the main ones that we use here with exponents. Okay, and then after this, we're going to move on to a video with surds. So if you struggled a bit with surds and you want to recap, look out for video number 2 on the same topic. Hope you have a great day and keep well. Bye-bye.